Hello and welcome to our tutorial video about the MIPI M-PHY frame generator software. We will show you how the MIPI DSGA can be used to test the physical layer of UniPro and UFS devices with the help of a single-lane DOT. To do this, we simply follow the steps in our tutorial. This is the connection screen of the M-PHY frame generator. The first step is to connect to the instruments. There are three different options for the pattern generator: the Keysights M8020A, the M8020A, and the MIPI DSGA. The MIPI DSGA can be used as a standalone instrument to configure the DOT for transmitter testing. To do the receiver testing, we need a J-BERT and a DSGA. The DSGA will take care of the DOT configuration, while the J-BERT will send the high-speed test pattern. Today we are going to select M8020A as the J-BERT. It is possible to select multi-channel configuration, but when the DOT has only a single lane, we will be using one-channel mode. Here we need to give the IP address of the M8020A. Please select the DSGA with the corresponding IP address. We press the Connect button. We click on Initialize Instruments. Now that the initialization of the instruments is done, we are going to generate the required UniPro sequences. We select UniPro Script Generator. Once we do this, we can see two things in the sequence area: the generic sequence and the output sequences. The generic sequence contains the basic structure how the sequence file will be for the test. Any changes made to this file will be carried over to the generated test sequences. One test sequence will be generated for each combination of gear and tested lane. Depending on the selection for test mode, either the transmitter test sequence or the receiver test sequence will be generated. Today we will demonstrate the receiver test. In the transmitter response field, we can select whether the DOT will be configured to respond with the frame and error counters in high speed or in PWM gear. Since the DSGA is a PWM capable instrument, we are going to select PWM. There is also the possibility to select between the two different patterns of M-PHY, ZJT pad and ZR pad. Here again, depending on the number of channels supported by the DOT, we can generate the sequences for one channel or multi-channel mode. Right now, I'm going to select only one channel since the DOT supports only one channel. With the transmitter amplitude option, it's possible to tell the DOT to respond with large amplitude or small amplitude. Most important of all, we have the different timings which set how much idle time we give the DOT in between PACP commands to react to them before issuing a new command. For example, the gap before the PACP packets, the gap after PACP packets, and between the burst. All the timings can be set here. Gap between bursts and stiff end states and all other gaps are filler symbols. If we want to set some custom packets, for example when we want to set some custom registers, we just give the address and its value here. Then it will be modified in the generated sequences. After all the settings are done, we click on Generate Patterns. The patterns will all be generated and stored in the output sequence directory. Here we have to set the different high speed and low power timings according to the DOT capabilities, and also here we can select the levels of the reference clock and the data generators. Also we can load previously saved setting files. We have already made a setting file which works for the DOT. Now we will test HS Gear 1A configuration. With the settings file, all the saved timings and the different levels are loaded automatically and also applied to the instrument, which is usually done with the Apply button. Here we can see the differences in the HS prepare length, HS sync length, store length, which was saved in the setting file. It is downloading the sequence, and now we can see that it is in the sleep block. The pulse sequence state can be selected in the options part. If we unselect this, the sequence state will go away. And if we select it, we can see the status of the sequence which is being sent from the instruments. Right now the sequencer is in the initial block which is sleep and when we need to click on the manual break. At this point the DSGA sends the link training commands to the DOT. We need to click on manual break one more time so that M8020A starts transmitting the test sequence. When we ask for frame and error counter requests, we can see the responses on the oscilloscope. For the DOT to respond this, we first need to configure the DOT. The DSGA does the link training and configures the DOT to receive or send the signal at a particular data rate. We send a hardware reset to the DOT every time we do the link configuration. Now the instructions need to be sent to the DUT to come out of Hibernate. After that, the number of lanes is set and the transmitter and receiver gear must be configured. So different kinds of registers can also be set in the sequence file, which is sent to the DUT. Once the link configuration is done, we will send the test pattern, and after sending the test pattern, we ask for the mode, frame counter, and the error counter. These are the 3 packets which we are asking from the DUT, and the DUT is responding it, which can be seen on the oscilloscope. Now we are going to demonstrate how to configure the scope decoder so that the DUT responses can be seen on the screen. We have to go to the setup and then to protocol decode. Here we have to select MIPI M-PHY UniPro and the UniPro version. In the data source, we select the oscilloscope channel where the transmitter normal output is connected. Here we go to the manual setup part and set the trigger level to around 100 mV. And for the clock recovery part, we need to select MIPI M-PHY PWM. This is shown here. We close this dialog and turn on the protocol decode. So right now it is on, and hence we are seeing the PACP packets. Let's see the content of the PACP packets as well. If we do a single shot, we can see the PACP information here. We click to get all the information in the PACP packet. Also we can see the CRC either is good or bad. Right now it's good, and by the way, we can also see other contents of the PACP packet here. We will go back to the run state and again the packets can be seen. This is how we check the PACP packets using an oscilloscope. Now we will find out how the DUT responses can be captured on the DSGA analyzer. We select Tools and then Pattern Coding. We need to click on the analyzer settings. There are 2 different choices, M8020A and DSGA. We select DSGA. Since we have connected only the complement of the transmitter output to the DSGA analyzer, we have selected single-ended mode and complement. If we are connecting both, the normal and the complement TX of the DUT to the analyzer of the DSGA, we need to select differential. We click on Apply and close the dialog. We click on Get and Counter. Here we find the number of received frames reported by the DUT. If we click on Get and Counter again, the frame counter increases, meaning the DUT has received more test packets. We see that there are no errors and the frames are received from the DUT. With this, we make sure that the DUT is working fine and we can proceed to do the tests using ValueFrame. This is all about how we can test the DUT. To change the timing and configure a different HS gear, we can go to the timing setup here. In the timing setup dialog, we have different possible high-speed gears. Right now we did the test for gear 1A. Let us choose gear 1B and change the data rate at which the M8020 is sending the packets. We change the data rate here, click on Apply, and we see that this data rate will be applied to the M8020A instrument. Now we have changed the gear, and this is the reason why we can see there are no packets. We click on Apply again. And again, it is in the sleep block. We have to make sure it comes out of Hibernate and start sending the test packets again. PACP packets can be again seen on the oscilloscope now. In the sequence name, the text between square brackets is a wildcard. When we change the gear in the timing setup, the sequence file automatically changes, and during the link training the DUT will be configured correspondingly. We do not need to go and change the sequence file again, we just need to change the data rate. After clicking the Apply button, we will see the results on the oscilloscope. This is one more advantage of our software. There are other wildcards as well, for example mode and amplitude, and is not only limited to HS gear. That's it. This is how we can test the DUT using our DSGA in UniPro or UFS mode. Hope we were able to give you an idea about our MIPI M-PHY solution. Thank you for watching.